Suppose the charge of a proton and an electron differ slightly. So usually the charge of proton and electron are equal to each other. So in this question we are considering, so they differ by an amount slightly. Okay. So one of them is minus E and another is E plus del E. So if we take the charge of electron as minus E and we have to take the charge of proton as E plus del E. So that slight differences here is del E. Okay. So if the net of electrostatic force and gravitational force between two hydrogen atom placed at a distance d apart is 0, then del E is of the order of, okay, so we have to find the that slight difference value. Usually the charge of electron and charge of proton is equal to each other, but in this question we will take the charge of electron is minus E and charge of proton is E plus del E. So if the net electrostatic force between two hydrogen atoms are there, if they are placed at a d distance apart, okay, d meter apart, okay, so if the gravitational force and the electrostatic force value is 0, net of these two value is 0, then the order of delta E will be, we have to find the approximate range of del E. Okay, as per the given condition we have to take the charge of electron minus E, okay, and charge of proton is E plus del E. So we have to take the two hydrogen atom. This is atom 1 and this is atom 2. Okay. So the first atom contain one electron and one proton. Second one contain one electron and one proton, and these two are separated by a distance d. Okay. So the net charge on this is, so it contains one electron, that is minus E, and charge of one proton is E plus del E. So we can cancel these two. So the net charge on the first hydrogen atom is delta E. Okay. So second one also contains the same electron and same proton, and this charge is also del E. Okay. Now we have to take this value as Q1 and this is Q2. So as per the given question, the net of electrostatic force and gravitational force are equal to each other. So we have to equate that. So if you add them together, their sum is 0, which means these two forces are equal in magnitude but acting in opposite direction. So then only their sum will become 0. So electrostatic force is a repulsive force because the charge is same kind, right? For same kind of charge it is repulsive. In case of gravitational force, that is attractive force. So their values are equal but their direction is different, so that's why their sum is 0. So we can equate their magnitude, Fe equal to Fg. Here the Fe indicates the electrostatic force and Fg indicates the gravitational force. On the formula for electrostatic force is K Q1 Q2 by, instead of R square and going to use D square. In case of G, gravitational force we have the G m1 m2 by R square. Here the distance between the two charges d. Okay, now we can cancel the d square on both sides, so we only left with K Q1 Q2 equal to G times of m1 m2. So m1 and m2 indicate the mass of hydrogen atom. So m1 indicate the mass of the first hydrogen atom and m2 indicate the mass of second hydrogen atom. Okay, and Q1 value is del E and Q2 value is del E. Okay, and K value is 9 into 10 power 9. Just substitute the value, we will get value of K is 9 into 10 power 9, and Q1 value is del E and Q2 value is also del E. And the value of G, universal gravitational constant, and G value is 6.67 into 10 power minus 11. Okay, that is the value of G. And here we have the mass of hydrogen instead of m1 and m2, so I can write that as mass of hydrogen atom whole square. Okay, so this value is given in the question, we can use this here. Okay, so just find the value of del E here. You will get del E square equal to 6.67 into 10 power minus 11, and mass of hydrogen atom is 1.67 10 power minus 27. 1.67 into 10 power minus 27, here I have the whole square, and I am going to take this value of k to the denominator, so I will get 9 into 10 power 9. Okay, so if I solve this, I will get roughly around 6.67 into, so I'm just rearranging the terms, 1.67 into again 1.67, and this 10 power minus 11 and 10 power minus 54. 27 times 2 is 54. 10 power minus 54. Again I have the 9 into 10 power 9. So if I multiply these all first three terms, you will get approximately 18.601 into, and these two become 65, I think so, 65. 10 power minus 65, or 11 plus 54 is 65. Okay, and next you have the 9 into 10 power 9. Now you can divide these two, so you will get 2.06 into 10 power minus 65. You can take this to the numerator, 10 power 9, that will become 10 power minus 9. So you will get approximately 2.06 into 10 power minus 74. So this is del E square value, but we need the value of delta E. Okay, so I have to take the square root for this. Okay, so if you check the answer, you can see only the 10 power value is there, so you can ignore this term. Okay, you can simply ignore this term, just find the square root of this value. So the square root of 10 power minus 74 is 10 power minus 37. So you have to divide this number with the 2, so you will get 10 power minus 37. The answer is B.